Hello, welcome to 2H TV. In today's tutorial, we are going to look at how to give solubility product expression for a given compound. So we are going to look at how we can easily write out the solubility product expression if compounds are being given to us. So we have some examples of compounds that we are going to look at in these lectures. Then we try to write the solubility product constant for it. Then in our subsequent tutorial, we'll be looking at how we will use these expressions, the understanding of this expression to work out a given example as to find the solubility product constant value or concentration of the given cations or anion. So these are the various examples that we are going to use to express solubility products. Now, they said we should give the solubility product expressions of the following. We have barium sulfate, we have the second example to be iron 3 hydroxide, we have calcium phosphate, we have silver chloride, we have calcium sulfate, and we have the fifth example to be Cu3 brackets open ASO subscript 4 all into brackets is giving us 2. So these are the examples given to us, and we try to write the solubility product expressions for them. So let's just quickly do that. So let's look at our first example. So example 1 is what? Barium sulfate, right? So to find the solubility product expression, you should know that the solubility product expression is denoted as Ksp. So anytime here Ksp is the same as solubility product constant, right? Now, barium sulfate, to find its ions, it must be dissociated. So writing your barium sulfate, when it dissociates, it produces a reversible reaction. We will form our barium ion plus SO4 ions. Now, we know that SO4 is having a charge of what? -2. -2. If that should be the case, once they all have 1:1 ratio, it means that they were having a charge of 2:2 and they cancels each other's effect, right? So this is how the ions would be if it has dissociated. Now, to simply write the Ksp expression is equal to concentration of what? Barium exponent 2 plus multiplying the concentration of SO4 2 minus. Now, because the ratio is 1:1, we don't raise to the power anything, and we don't multiply. It's assumed that the ratio is 1:1 because they are all 1:1, right? So we multiply 1 by Ba2 plus, and we multiply 1 by SO4 2 minus. We raise to the power 1 because the ratios are 1:1 ratio. Now let's look at the second example. So example 2, that is iron 3 hydroxide, right? When we dissociate this, we will produce iron and what? Hydroxide, right? Now we said that the number in front of the anion becomes the charge of the cation. So in front of hydroxide we have 3, so it is ion 3 plus, and in front of the cation we have only 1, so 1 minus. So simply you check that is the equation balance, right? We have 1 ion here, we have only 1 ion here, but we have 3 moles of what? OH. We have only 1 mole of OH, so we put 3 in front. Now our equation is balanced, so we try to write the Ksp of it. So simply the Ksp now is equal to concentration of what? The ion 3 plus, because it's 1:3 ratio, We multiply the ion 3 by 1 raised to the power 1. Then, because this is 3, we multiply it by 3 and we raise to the power 3. So this is how you write the KSP, the solubility product constant of iron 3 hydroxide. So let's quickly look at the third example, example 3. So example 3, we have calcium phosphate, right? So when we dissociate this, we'll produce calcium ion plus what? PO4, right? So in front of the cation, we have 3. So it becomes the charge of the anion. So we have 3 minus. Then in front of the anion, we have 2. So the 2 becomes the charge of the cation. So 2 plus, right? Then the next thing is we check whether our equation is balanced. Now, we have 3 calcium, but we have only 1. So we put 3 in front of the calcium. We have SO4 to be 2. We have SO4 to be only 1 here. So we put 2 in front. Now our equation is balanced. So let's quickly write the KSP expression of it. So your KSP now is equal to concentration of what? So 3 Ca2 plus. Because the ratio is 3 is to 2, when you multiply it by 3, you raise to the power 3. Then multiplying 2PO4, 3 minus, the mole is what? The ratio is 2. It's having 2 moles in front, so it's raised to the power the same number. So this is how you do the expression. So let's quickly look at the rest. So let's look at example 4. So example 4, we have silver chloride, right? When it dissociates, it will produce silver plus what? Chlorine. Now, what is in front of chlorine? 1. So it means the charge of silver is 1. And what is in front of silver is 1, meaning it is minus 1. So quickly, the KSP expression is equal to concentration of silver multiplying the concentration of Cl minus. So this is simply how it is. Let's look at question 5. Question 5, we have CaSO4, right? Then we dissociate this to produce Ca ions and SO4 ions, right? But we know that calcium is having a charge of +2, so definitely SO4 will having a charge of -2. They cancel each other's effect, so 2 plus 2 minus, right? So this is how it is. So quickly, it is balanced because we have calcium to be 1 1, SO4 1 1. So the KSP is simply equal to concentration of calcium 2 plus multiplying the concentration of SO4 2 minus, right? And let's look at the last one, question 6. We have Cu3 brackets open AsO4, right? When you dissociate this, you produce Cu ions and AsO4 ions, right? So what is in front of the cation becomes the charge of the anion, so 3 minus, and what is in front of the anion becomes the charge of the cation. There is 2 here, sorry, so it becomes 2 plus, right? So we check whether it is balanced. We have calcium 1, we have copper to be 1 here, we have it to be 3, so 3 in front. We have ASO4 to be 2 here, we have it to be only 1 here, so we put 2 in front. Now our equation is balanced, so we quickly write the KSP expression of it. Concentration of 3 Cu2 plus, right? Because there is 3 in front of the Cu2 plus, it will raise to the power that same number, multiplying 2ASO4 3 minus, right? Because there is 2 in front of it, we raise to the power that same 2. So this is how you write the KSP, the solubility product expression of a given compound. Make sure you dissociate the compounds into its ions, then you try to balance it, right? The charges, the number in front of the anion becomes the charge of the cation, the number in front of the cation becomes the charge of the anion. Then you try to balance it, right? Thank you so much. In our next video, we will look at how we use this understanding to work examples. Bye.